Alright, here's the homework questions from 12.2 and 12.3. I think that's what they're about. Yeah, pyramids, and then also cones. Here's some questions that I got from the first class, and I added to that for the second class, and here you go. These are some of the ones I chipped away at during school time. This one, they gave you this pyramid. Looks like it's an octagon. Each side is 3. Yeah, so the perimeter is 8 times 3. The hard part is finding slant height. They give you the lateral area, and you know that slant height times perimeter times half has to be the area. So you just do some algebra magic there, and there you go. This is a little tricky. I hate doing these. You got to find the apothem uh, of the hexagon. This is a hexagonal pyramid, and they give you the length here and the length of the base edge, and then they give you a lateral edge, which is really not very helpful for anything. If you build a triangle on the inside here that uses the radius of the hexagon and the edge, you can find the height of the thing pretty easily, which isn't too bad. And then you figure that out, and there you go. Volume, right, I need to know height, and I need to know area of the base. Area of the base is all this stuff down here. I need to know apothem to find area of the base. Apothem would also be helpful if I needed to find slant height of this thing. But I don't. So here we go. 22b, yeah, these were really bad. You had to figure out the height of the thing and the slant height. All you know is the edge, and what else did you must have had to know something else? Oh yeah, this other edge over here is 4. So looking at the face of the the base of this pyramid, you have to figure out the apothem sort of, which is here the square root of 3 in a 30, 60, 90. If this is 3, because this is 6, this is 3, but it's the long leg of this little 30, 60, 90. So from here out to the edge, that's the square root of 3. That's in a right triangle with H and L. But first, let's find L with the outside edge of the pyramid and that half base thing. You figure out that L is the square root of 7. So if L is the square root of 7 as a leg of V to, I guess this is M to C, L is a hypotenuse of V to M to O, which is this one. So once I have that L square root of 7, and I knew this apothem here was square root of 3, I can use that and a right triangle Pythagorean theorem and figure out what H is. That is no picnic. That apothem stuff really wears me down. All right, here's number 6. I'll kind of do these in order now. Number 6, we have a pyramid. They told us the lateral edge is 10 and the height is 6, and we're supposed to find slant height and base edge. So we need L, and we need, I guess I could call this X. We need to find X. Okay, right triangles all over the place. I think I like this one the best at first because we have a 6 and a 10 in a right triangle where the if you're looking at the floor of the pyramid, this is like the radius of the square is the another side of that right triangle. There's a right triangle there. That tells me this is 8 with Pythagorean theorem. So this is also 8. So this side would have to be 8 square root of 2. That's kind of cute. That's a 45, 45, 90 right there. So this is 8 square root of 2. And then I got to find L. Look at that outside triangle. Might be kind of easy. There's a couple ways to do this. I could find, because I got to find L. L is the leg on a face side here with a 10, and then the 4 square root 2, I guess it would be from here to the corner, and I could figure that out. Or I could go 6, find out what this thing is, that would be 4 square root 2, and then this side here, I don't know. I kind of like the face. If you look at a lateral face, so this was base. This is a lateral face. And I know this is 10, this is L. And this is half of this edge. It's kind of like from here to the corner. 4 square root 2. So I would say 4 square root 2 squared plus L squared equals 10 squared. 10 squared, that's easy. 4 square root 2, that's 16 times 2, that's 32. So L is the square root of, gosh, that's 68. 2 comes out of that. I believe it's 17. Yeah, okay. That's a fun one. Okay, that's 6. Next one, I guess, would be number 11. Can I fit 11 right here? Let's pretend I can fit 11 right here. All right, 11. Let me draw it. I'll come back. Okay, it's a pyramid. It's got a base edge of 6 and a square pyramid and a height of 4. Lateral area, I need to know. Whoops, I should change color. It's half times perimeter of the base times lateral edge. Perimeter of the base isn't bad. It's just 4 times 6. But I need to know what the L to put next. Okay, so this would be what the slant height looks like. This little thing down here would have to be 3 because that's a square, That's 6, so that's 3. This then, easy Pythagorean triple, that's a 5. Okay, so this is 60. Total area is lateral area plus a base, which is 60 plus the area of the base, which is just 36. So this is 96, and this is 1/3 times the area of that base times the height. Well, the area of the base I just figured out was 36, which is just 6 times 6, and the height they gave me is 4. So this is 4 times 4, which is 4 feet. Okay, nice. All right, this isn't a great drawing. Actually, you can't even see my 12 in the middle anymore. The height of this thing is 12, and it's a rectangular pyramid, which is just weird. We haven't had any of those yet. The straight up height in the middle is 12, and there's one side that's 10 and one side that's 18, and they want you to find these sort of different slant heights. Well, they're just found by looking at different right triangles. If I go this way, and I call them A1 and A2 I'm looking for because they're both in part A. 12 squared plus, and I guess this would have to be 9, wouldn't it? 12, 9, and what makes a right triangle, though that would be 15, if I know my Pythagorean theorems very well. This one down here is half of 10, because it's half of this side of the rectangle. So this is 12 and 5. This would have to be 13 in a a squared plus b squared equals c squared situation. So the diagonals are, yeah, should I write that out? You can't really see what I did there. The 15 I got from a squared plus b squared equals c squared. That turns out to be true, so there's where I got that one. And the other one was 5 and 12. 5 squared plus 12 squared happens to be 13 squared. So they picked nice numbers here, so it would work out. All right, part B. So that's part A. That's an A. Part B is find the lateral area of the pyramid. Well, I would probably do this up by taking up the, counting up the triangles. Front and back are going to be triangles that look like this, that have an 18, a height of 13, and I guess that's it. So this is, there's 2 of them, so let's do that. 2 times half, so it's 2 of these. 2 times half times 18 times 13. And left-right sides, there's 2 of them again, and they look like this. And they are 10 there, and they have a height of 15. Now you're probably looking at this going, wait a minute, this one has a height of 15, this has a height of 13, how can they possibly be at the same point? Well, we're talking about the heights, like if you're skiing down the slope of that pyramid. And yeah, that can be different than that, because one is going to be, they're going to be angled differently. This long one, I'm guessing, well, it's angled out farther, because look, this side's 18, so it's going to have to slope more gradually than this one, will be a little more straight down. So again, it's 2 times base, sorry, half, times base times height, which is, oh, this one I almost did in my head, 2 times half is gone, 10 times 15 is 150, 18 times 13 I can't do it in my head. Maybe I should be able to, but I can't. It's 234. So the total lateral area is add those up, and that would be 384. Nice. And that's it. Oh, this is how you do volume. But they don't have you do volume. Okay. Okay, I renumbered these things at the top, so they're kind of in an order. I'll try to stick with the order now. I can skip 22B because I already did that one in class. But anyway, 19, they're saying, what's the ratio of the pyramid compared to the block here? Well, if this thing were actually the entire block, I think this is the best way to do it. If I took that entire block and I first cut it in half, like I cut it with a plane, change color here. If I cut it with a plane along this line here, and I cut that straight down, so I've got the thing basically cut in half. It would cut straight through the floor like this too. So take this part away back here. Take that out. I've just got this triangular thing. The base of that, and by base I mean, let's look at the top. The roof of that now is just this triangle here, which is the same as this triangle here. Now I have a prism that would perfectly box out this pyramid. This prism would be 3 times the volume of this pyramid. So yeah, this pyramid is 1/3 of this half block. So since it's 1/3 of, say, half, it's going to mean that this is going to be, I'll say this thing here is 1/3 of half of block. Well, they want to know, they don't want to know it this way. They want to know, well, how much is it of the entire block? Well, third of half is a sixth. I like that explanation the best. You could also think volume is area. I mean, it's going to be basically the same. Area of the base times the height times a third. Well, the area of this base, thinking of this thing is the base. The area of that is one half of the base of the original one. So the original big block. So it's kind of like half of base times height times a third. And again, you're going to have a half and a third being multiplied. And you're going to get 1/6. Okay. All right, here's one of those questions that people would waste a lot of time on the test about if they weren't thinking. Those times I don't have sympathy for people who say they didn't have enough time on the test, because this is really silly. They're saying, okay, we have a pyramid and a prism that have the same base and the same height, but it doesn't really use the word same. They say they both have an 8.2 height, and they both have an area of mid in the base. Well, if they have the same base and the same height, I mean the prism, let's go this color, volume of the prism is base times height. I don't care what those numbers are, but for now let's just think about that. Area of the pyramid is 1/3 base times height. Guess what the ratio is? If this much is the same, the ratio, like that kind of stuff, is the same. So the ratio is 1 to 3. This pyramid has 1/3 of the volume of the prism, and that's just the way it is. And yeah, you don't have to worry about calculating anything. Don't waste any time on this kind of thing on the test. All right, here's the one that bothers me. All right, so we have an equilateral triangle base. As I'm doing these, I was doing the review ones for the test on the same day. These are way harder than the ones in that check review. This is much better practice for the test than the chapter review, I think. All right, so the equilateral triangle, I know the height is 9. They tell me the A to M is 9. What's weird about this is this mysterious location of the point O. This is 9, so that is square root of 3 times longer than this. So to find this thing, I have to go 9 divided by the square root of 3, which is 9 square root of 3 over 3, which is 3 square root of 3. Right, so take that times square root of 3, it'll turn into 3 and add 9. Okay, so that's 3 square root of 3, so the side of the thing is 6 square root of 3, which might be good to know. The distance from O to that's a tricky thing. I don't know if you've seen this enough by now, but that's exactly 1/3 of this whole thing. I mean, I know right now this is going to be 3, but if you don't like that, if you can't remember that, if you don't believe me, here, this is 3 square root of 3. Now this is the long leg of a 30, 60, 90 here. If I connect this to the corner, it's going to bisect this angle. This is then going to be 30. So I have another 30, 60, 90. This is 3 square root of 3 is 3 times longer, sorry, square root of 3 times longer than the short leg, so that makes this 3 and this 6. I could also talk about this thing and split it into 2 right triangles, and I get the same thing. I get this distance here. Fine. So that thing's 3. The distance right here is 3. Why did I need to know that? Well, I'm getting there. I needed to know... Yeah, I need to know the height and the leg. I also know if this is 10, then this thing over here is 10. All these edges that come straight down are 10. I think I want the 3 when I go to find H. First, I'm going to find L. This is like that 22B. Let's look about on the face, on the lateral face. I have, say, VMC. I know this is 10. I know this is 3 square root 3, and I'm looking for L. Okay, L squared plus 3 squared root 3 squared is 10 squared. Oh, that's 100. 3 squared is 9 times 3, which is 27. So L squared is that 73? Okay, I don't think 73 has a nice square root. No, it doesn't. It doesn't reduce at all or anything. Square root of 3 is square root of 73 is L. I can put that into triangle now with, this is an invisible hanging triangle here, with L, H, and 3. This is the square root of 73. I said 73. So H squared plus 3 squared equals the square root of 73 squared. Well, the square root of 73 squared is about the easiest thing I've had to do all day. And that's 9. And so H squared is 60. Oh, look, it's a nice number. H is 8. Okay, there we go. I'm going to have to pause this now and get back to you for the rest.